Welcome to our lesson on ratios, rates, and proportions. Our goals are I can write a ratio and a rate given information in words or pictures, and I can solve a proportion using cross multiplication. So there's another way to solve a proportion, which we'll discuss what that is, and we're going to focus on cross multiplication. We're going to first start with a ratio and a rate. Our first statement says a blank is a comparison between two quantities. And what we're looking for is called a ratio. Once again, it says a ratio is a comparison between two quantities or two numbers. There are three ways to write a ratio, and order is important. So we're going to use the examples below. The first example says 2 red marbles to 6 blue marbles. And we can write that three different ways. We can write 2 red marbles, and I'm just going to abbreviate red for marbles, and we can use the word 2, like they said here, to 6 blue marbles. That's one of the ways we can write it. The second way to write it is 2 red marbles, and then instead of the word 2, we're going to use a colon to 6 blue marbles. But perhaps the most useful way for us to write it is fraction form. So 2 red marbles compared to 6 blue marbles. So it says it's a comparison between two quantities. And in this case, we're talking about marbles. One set is red and one set is blue. So now let's look at the second example. This says there are 5 girls and 7 boys in Mr. Madison's class. So we would write that using words. We'd write 5 girls, and we can use the word 2, 7 boys. So that's one way to write it. The second way would be 5 girls, and we can use the colon to 7 boys. But the preferred way is 5 girls, written in fraction form, to 7 boys. And you're noticing that I'm labeling. So for the next exercise, you don't have to draw your labels, but these labels, and by labels I mean I'm stating what the numbers are referring to. In the future, I'm going to have you write that, particularly when we're working with word problems. So let's look below and see what you're being asked to do. So we prefer, first of all, to write ratios in fraction form because it's very useful. We can use them like a fraction. And so I'd like you to use the pictures below to write a ratio for each situation. So before you get started on this, you're going to notice spoons to forks, forks to spoons, but this particular type of problem confuses students. It says spoons to all silverware. And so when we write this, the spoons, we don't deduct them or take them away from all silverware. We still count them when we write all silverware. So what I'd like you to do is write the ratios in fraction form, and I'd like you to write a ratio, for example, A through F, and then restart this to check your answers. Letter A says spoons to forks. So we would write that, we'd count that there are 5 spoons, so we write 5 over 1 fork. And remember, order matters. Whatever comes first goes on top, whatever they mention second goes on bottom. The second example is forks to spoons. Well, there's 1 fork and there are 5 spoons, so we're going to write 1 to 5. The next one is mentioned. It says spoons to all silverware. That sometimes is tricky. Well, there are 5 spoons, but if we count all the silverware, including the spoons, 1, 2, 3, 4, 5, 6, 7, 8, 9, there are 9 pieces of silverware, including the spoons, because it did mention all silverware. Next, it says knives to all silverware. So like the other one, we're going to count the knives. There's 3 knives and there's 9 pieces of silverware. This next example might be a little bit tricky because it says forks and knives before we see the word to. So it's not comparing forks to knives, it's forks and knives all together. So there's 1 fork and 3 knives, so that's 4 altogether. And compared to spoons, there are 5 spoons. And final example says spoons and forks. Again, we add these together to knives. The word to is where we write the fraction bar or the colon. So in this case, we're going to write a fraction bar. I see 5 spoons and 1 fork, so we're going to say that that is 6, and there are 3 knives. So hopefully these are the answers you have. Let's go on now to the next page. Our next definition statement says a blank is a ratio that makes a comparison between 2 different types of units. So that is called a rate. And a rate, again, I want you to know, is a ratio. It's a comparison, just like a ratio is, only it says different types of units. So let's look at the example. Maisie measures her heartbeat at 12 beats per second. So before we were talking about silverware. Forks are silverware, knives are silverware. They were the same type of thing. But when we're talking here, we're talking about 12 beats per second, beats and 10 seconds. Those are 2 different measurements. Also, often a rate is talking about time. The second thing mentioned is seconds, years, days, weeks, some unit of time. But that's not always the case. But in this case, we would write this as 12 beats and to 10 seconds. So again, order is important. Our next unit mentioned, or our next definition, a blank is 2 ratios that are equivalent. So that's called a proportion. So when you hear the word proportion, it just means you're going to see 2 ratios that are equivalent, in other words, are equal to each other. So a proportion. At any time, if you need to stop this video and write these in your paper, that's great. So let's continue. So a proportion is 2 ratios that are equivalent. We often use a proportion to help us find an unknown quantity. In other words, solving a proportion can help us answer a question. And so we just finished our solving unit, and we're going to use our algebra skills in this unit. There are 2 ways we can solve this proportion. One is called scaling, and you may have used this before when you worked with equivalent fractions. And the next is called cross multiplication. So let's look at that. Let's practice scaling first. So if I look at this first example, 2 compared to 3 is what some unknown quantity is compared to 18. And you're going to notice there's an equal sign. So these are like equivalent fractions. And if I look down at the bottom, they gave me the bottom number on this ratio, and they gave me the bottom number of this ratio. This is my unknown. So if I look at this, how would I go from 3 to 18? And remember, if these are equivalent fractions, like equivalent fractions, we would either multiply or divide. So what number can I multiply or divide to get to 18? Well, I'd have to multiply by 6. So if I multiply by 6, that would give me 18. And when we work with equivalent ratios, we do the same thing for both the numerator and denominator. So the wonderful thing about using a ratio in fraction form is we can do the same things that we do to fractions. So that means that x would have to equal 12. So x would equal 12. So let's look at that comparison if I write that. It says that 2 is to 3 as 12 is to 18. And if I would reduce this, I would certainly get 2 over 3. So next, let's look at this next example. You notice that the unknown is in a different place. 4 is to 5 as 16 is to some unknown quantity. So just like we did in this example, I'm going to look at the 2, in this case what we're going to refer to as the numerators, this and this have a relationship. And since I'm working with them like they're equivalent fractions, what would I need to multiply or divide 4 by to get to 16? Well, I'd need to multiply it by 4. So we're going to write times 4, which means the bottom number, I would also, the numerator in this case, I'd multiply that by 4. So that means x must equal 20. So if I replace that with 20, 4 is to 5, as 16 is to 20. Again, if I look at this like it's a fraction and I reduced it, I would get 4/5. Finally, this last example says 7 is to 6, as our unknown quantity is to 30. So I'm going to look at the bottom, the denominators, because these are the two that are given. What can I do to 6, either multiplying or dividing, to get to 30? And so in this case, I would have to multiply by 5, which is what I would do to 7. I'd multiply by 5, leaving x equals 35. So let's look at this. 7 is to 6, as 35 is to 30. And again, if I reduce this, I would indeed get 7 over 6. So I'd like to show you one more example, because in all three of those examples, I did not demonstrate one that involved division. So if we were given an example like this, where the numbers, I have 5 and 20, and then x and 12, you're going to notice that if I multiply this by 4, I would get 20, but I don't know what this number is. So I can either use my logic and say, what can I multiply by 4 to get 12? Or we could just use division. I could start with the 20, and I could say, well, I can divide that by 4, and that would give me back this 5. So if I divide this by 4, if I divide my 12 by 4, I'm also going to get back the answer. In this case, x would equal 3. So 5 is to 3, as 20 is to 12. Okay, now let's go to cross multiplying. You're going to notice it's this cross multiplication. You're going to see why in a minute. We also refer to it as the butterfly method. So the word cross means that we're going to make a cross. We're going to make an X shape, but we're going to look at these kind of like they're butterfly wings. So when I do this movement here, that means that I'm taking 2 times 18. I'm multiplying. Then this is going to be the butterfly body, reminding me to put down my equal. So that right there reminds me to put equal. And here comes the other cross. I'm making an X with these two, but it also looks like a butterfly wing. And so that is 3 times X. So I'm cross multiplying. I'm crossing this way, and I'm crossing over this way, and this is just a reminder, the body is reminders to bring down the x. So what I'm going to get is I'm going to get 36 on this side, and instead of using parentheses, if I have a number and a variable, I can just write it as 3x. Now, some of you are not very fond of seeing this written backwards, so if that happens, there's another way we can do this. I prefer, when I'm doing my cross multiplication, to always start where the x is. So I would have started with this butterfly wing, because it really doesn't matter. And I would have gotten 3 times x. The body would still remind me to put my equal down. And then here I would have gotten 2 times 18. So I would have had the same thing, only it would have been with my x on the left side. It's completely up to you, or you can go ahead and do it this way, and if you hate seeing it that way, you can switch it around. So now, here's where our solving skills are going to come into play. 3 times x. You can see up here we use multiplication. Side by side means multiply, so we're going to do the opposite in order to solve this. We are going to divide by 3. And that's because 3 divided by 3 is 1, and 1 times x, there's my x by itself. And 36 divided by 3, you can always use your calculator, would be 12. So the answer is 12. So this would mean 2 is to 3 as 12 is to 18. You may have noticed we got that exact answer when we use the scaling method, because we're using the same problems, because I want to show you how this method is going to yield the same answer. So we're going to use the butterfly method again, cross multiplying. I'm going to cross starting with 4 times x. So that's what this means. When I do this wing, that means I'm multiplying. Now I'm going to draw the body to remind myself to bring down the equal. And then I'm going to do the other butterfly wing. I'm cross multiplying, so that means 5 times 16. Or I could write 16 times 5. The order that we write these two numbers do not matter, but these two numbers have to go together, and these two numbers have to go together. So we would prefer to see this as 4x. And 5 times 18, again, would be 80. You can use your calculator, but for the sake of time, I'm not going to do that. I'm going to solve by realizing 4x means 4 times x, so I'm going to do the opposite. I'm going to divide by 4 on both sides. This is my solving step. So that leaves x on this side, and x equals 20. And if you look at this example, that's exactly the answer we got when we used the other method. So I'd like you to take a moment and try example number 3, and then come back and see if you agree with that answer. All right, if you cross multiplied, this is what you should have had, the two factors on each side based on the wings. They have to be, the 6 and x have to be together, and 7 and 30 have to be together, although you could put the order of these differently. This is what the answer is once we find the product of those two sides, but now we really want to know what x is. So we're going to solve 6 times x, so we're going to divide, the opposite is division, and we have x equals 35. I know this was a very long lesson, and I hope that you attended class today. Unfortunately, we're trying to introduce many concepts in a short amount of time. I'll see you next lesson. Thank you.